Recently, Ukraine has demonstrated a new cruise missile named FP-5 Flamingo, which from the first glance can play game-changer role in the conflict. In this video, we will review the Flamingo cruise missile from engineering point of view to unveil the hidden details in the system and determine how realistic are the characteristics given by Ukrainian side. After the first picture of the missile was shown to the public, Russian side was claiming that Flamingo is a modernization of old Soviet UAVs by Tupolev, Tu-141 and Tu-143. However, it is a complete mistake. While those UAVs have significantly different flight characteristics, much worse compared to Ukrainian missile. In addition, the most important difference is the aerodynamic configuration. Both Tupolev creatures have delta wing configuration with frontal canards, while Flamingo has classical aerodynamic configuration with main wing and the X-shaped tail assembly with fully movable fins. The specifications of Flamingo cruise missile are quite impressive. Weight 6,000 kilograms, warhead 1,150 kilograms, range 3,000 kilometers, cruise speed 900 kilometers per hour, service ceiling 5,000 meters, and the guidance is combined GPS plus INS. On the other hand, behind these awesome characteristics, there are some trivial engineering solutions, some of them even not being impressive at all, and more tend to cheap decisions to ensure fast manufacturing capabilities. First, it should be said that such aerial vehicle is not a missile by nature. It's more drone equipped with jet engine. The first surprise of Flamingo was during its presentation video, where Ardupilot interface was visible. Maybe it was used only for prototype, but anyways, it shows general philosophy during design stage to use maximum amount of cheap off-the-shelf solutions. On the internet, there were several pictures of nose section, where it is clearly visible that as a warhead, actual bomb is placed. Based on warhead mass provided by manufacturer, it can be assumed that most likely partially disassembled Soviet Fab 1000 bomb is mounted directly in the nose section of the cruise missile. Another point of interest in Flamingo is the engine. If we look closely to pictures, some details can be seen, which are similar to AI-25TL engine used on L-39 Albatros, the iconic training aircraft manufactured by Aerovodochody from 1971 to 1996. If you look closely to the nozzle, flame stabilizers can be seen, which are typical for AI-25TL engines. Another point is that these engines are still under production by Ukrainian company Motorsich. Based on these facts, we can conclude that Flamingo is equipped with AI-25TL engine. Therefore, it has thrust of 1,720 kg force. After these details are clear, it could be a nice idea to make a short comparison of Flamingo to various cruise missiles, starting from legendary V1, finished with Storm Shadow and Taurus. The idea of this table is not actually characteristic numbers, but coefficients derived from those numbers. If you look closely to the last two columns, there are given coefficient of payload, which is mass of payload divided by total mass of the missile, and thrust to weight ratio, which is thrust divided by total mass. These two parameters bring all those missiles to the same page by describing their flight dynamics with mathematical dependencies. As you see, coefficient of payload of Flamingo is approximately 0.19, which tells that payload of this cruise missile is around 19% of the total mass. Also, thrust-to-weight ratio is 0.29, which is more than enough for effective cruise flight. To go further with calculations, inverse Breguet equation can be used to define some aerodynamic properties of Flamingo. As we know, maximum range is 3,000 kilometers and cruise speed is 900 kilometers per hour. So the flight time should be range divided by speed, which is approximately 3.3 hours. Initial mass 6,000 kilograms. Fuel flow for cruise flight 468.1 kilogram per hour. So actual fuel burned equals to 1,560.33 kilograms. Therefore, final weight can be derived, which will be 4,439.67 kilograms. Thrust-specific fuel consumption for given engine is 23.1 gram by kilonewton second, which if we convert to kilogram by kilogram force hour will be 0.815. In the Breguet equation, range equals to velocity divided by specific fuel consumption, multiplied by gliding ratio and multiplied to a natural logarithm of ratio between initial and final weights. This formula can be rearranged in a way to calculate lift over drag, so-called gliding ratio, which will equal to 9.02. Gliding ratio is a crucial parameter for aerial vehicle, while it defines main aerodynamic characteristics and clearly defines how well aerial vehicle can fly. In a simple term, with no engine thrust, aerial vehicle with gliding ratio 9 can fly 9 kilometers forward while descending with 1 kilometer. From professional perspective, the value we got is lower than average. Such lift-to-drag ratio is typical for general aviation aircraft, but not for advanced cruise missile. This makes me think that motivation of engineers was to make cheap, relatively effective product with lower demands, which is visible even on the poor assembly quality of Flamingo. Another interesting point can be the wing of Flamingo, which is straight low aspect ratio with no twist, no taper ratio. In some pictures, the shape of an airfoil is visible at the root chord, and such shape is not typical for near transonic wing. Having straight wing and not using supercritical airfoil reveals the idea that at near transonic speeds, shock wave can appear at various sections of geometry, what will bring additional wave drag. However, this is just an assumption, and nothing can be said without actual computational fluid dynamic analysis. In general, FP-5 Flamingo seems to be a dream aerial target for anti-air systems. On the other hand, we are not sure that Russian side will manage to shoot down every Flamingo flying to its target. And if it reaches the target, it will be real death punch.